Okay, so let's look at this problem. Let's see that. So we've got students set up an incline plane surface as shown in the figure at an angle of 10 degrees to the horizontal. So they place a frictionless trolley of mass 0.5 kilograms at the top of the incline so that the distance from the front of the trolley to the stopper at the bottom is 3.5 meters. Okay, so there's quite a bit of nice information there, and let's just highlight some of the important ideas we need to draw on. Okay, they release the trolley from rest, find that it takes 2 seconds to get to the bottom. Alright, so we have a trolley that's experiencing a force due to gravity. Mass times gravity pointing down, but because it's on an angle, that's going to have some components, and you've got sides of the right angle triangle here. So this side, it's good to point out this side here is the opposite side to the angle. So we will have a force of mass times gravity times sine of the angle. Alright, and that's the one we're going to be drawing on. So you always start with Newton's second law, or the sum of angles that act on the trolley must add up and then equal to mass times acceleration. So we have the force that it will experience is the sine theta of mass times gravity. Okay, and that is the force that is acting in this direction and pointing down the plane. Okay, it's the component of weight force. And acceleration can easily be worked out as gravity times sine of theta. Now let's plug in our values. Gravity is 10, theta is 10 degrees, and we'll plug it in and calculate, and we're going to get 1.74. Okay, next let's look at this one. Now we've got the same amount of distance down the plane, but it's friction now, friction force that's involved. Alright, and this time it's going to take 6 seconds to slide down the plane. So because there's a friction force involved, we don't know what that force is, so we can't. They are. So because of the friction forces unknown, we can't use F equals ma, okay, to work out acceleration. So we have to use this rule for constant acceleration formula, okay, and it is for a displacement of 3.5 meters down the plane and a time of 6 seconds it takes to go down the plane. Now, since it's been released from rest, we've got initial velocity of 0, so that's important to include. And we go ahead and we're going to solve for A. So we put all the values in, and we calculate for A, and we get A equals 0.19. Okay, so that's the acceleration that the block experiences. Now we can use F equals ma, and put in our values. Now there we go, that's an important thing. That there is the sum of all forces now. This is the force due to gravity pulling down the plane. However, this one here is friction force pulling it back up. Okay, so we have to subtract the friction force there. Then when we now rearrange the equation, solve for the friction force and sub all our values in, we're going to end up with that as our value for friction force. Okay, alright, I hope that helps. And to 2 decimal places, we'll have that value. That's fine.